This is going to be a flip video about valence electrons, and this is actually an introduction to valence electrons. There's more to come, so this is just the basics. Let's first start by reviewing what we've been doing so far, and that's ionic versus covalent, known as also ionic versus molecular compounds. In an ionic compound, the atoms are being held together by ions. In a molecular compound, the atoms are being held together by what we call covalent bonds. So some real quick differences that you should know between these two are ionic compounds are between metals and nonmetals, metals and nonmetals, whereas covalent or molecular is between a nonmetal and a nonmetal. Okay, great. In covalent, we use prefixes to name. We use prefixes. In ionic, we do not use prefixes. All right. In ionic bonding, electrons are being transferred. They're being transferred, meaning we lose or gain electrons. In covalent bonding or molecular bonding, electrons are being shared. Electrons are being shared. So let's just quickly talk about what that means to share versus transfer. So this is an ionic compound, a metal and a nonmetal. And what's happening here is chlorine snatches up one of the electrons from sodium. And so now chlorine has an extra electron, so it turns negative. There's its electron. Sodium lost that electron, so it turned positive. This positive and negative, opposite charges attract. That's what's happening in ionic bonding. In covalent bonds, that's not what's happening. Electrons are being shared. So hydrogen and oxygen come close to each other, and if you notice, hydrogen says, I have an electron to share, and oxygen says, I have one too. And so sharing happens. What's yours is mine, what's mine is yours. Same thing over here. All right? So you know that compounds are either ionic or molecular by looking at them and finding their elements on the periodic table. Sulfur and oxygen, nonmetals, so those are covalent. Sodium and chloride, metal, nonmetal, that's ionic. Carbon and oxygen, nonmetals, covalent. Calcium and chloride, metal and nonmetal, ionic. All right, good. Moving on, how does this tie into valence electrons? Well, valence electrons are the electrons that are actually used in bonding. So they're the electrons that are either being transferred, if it's ionic, or the electrons that are being shared, if it's molecular. So let's write that down. That we are using valence electrons in bonding. Now, depending if you have an ionic bond or a molecular bond, you know what's happening to them. Okay? All right. Each element, then, has a certain number of valence electrons to begin. So, here's my periodic table. Let's take a look at that. In my periodic table, over every column, I've now put a black number, if you see here. Do not confuse it with the charges. Okay? This black number represents how many valence electrons these elements in column 1 have. These represent how many these elements have. So everybody in column 1 has one valence electron. So hopefully you remember what a valence electron is. A valence electron is the electrons in the outermost part of the atom, So let's take a look at an atom. If you notice here, I have lithium. Here's lithium. Here's a representation of an atom. It's obviously not the most accurate, but it works very well for us. Lithium is element number 3 on the periodic table. It has a proton number of 3, so I put that in the nucleus. And then if you notice here, I've drawn some, what we like to call these energy levels. I've drawn 2 energy levels for lithium. And in lithium's energy levels, there are electrons. Okay? Lithium, neutral lithium, has 3 electrons, right? Because 3 protons means 3 electrons. I'm going to put 2 in its inner shell, and then I'm going to put 1 in its outer shell. This 1 electron in the outermost shell, or outermost energy level, shell or energy level, is the valence electron. V for valence, E negative for electron. Everybody in column 1 has 1 electron in the outermost shell, and that's called a valence electron. Okay? Well, let's take a look at sodium. Here is sodium. It has a lot more energy levels, but that shouldn't make a difference when it comes to valence electrons. So sodium has 11 protons. I'm going to put 2 there, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. There we go. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put 1 in its outer energy level. So all you have to know for right now is that sodium has 1 valence electron in its outermost shell, because on top of column 1, you're going to memorize that there's 1 valence electron. Column 1 for 1 valence electron. All of these have 1 valence electron. All right? So if we were to continue on to do column 2 right now and do beryllium, and here's beryllium's energy levels. Beryllium in its outermost should have 2 valence electrons. 1 right there, 1 right there. Why? Because beryllium's in column 2 and everybody in column 2 has 2 valence electrons. Now the nice thing about this is the number above the column 1, 2, 3, 4, 5, 6, 7, 8. Remember, that's a way to number this periodic table. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Also responds to or correlates to how many valence electrons. Column 1, 1. Column 2, 2 valence electrons. Column 3, 3 valence electrons. 4, 4, 5, 6, 7, 8. So everybody in column A has 8 valence electrons. 8 valence electrons. Okay, good, easy. Now, the goal is, the reason why everybody bonds and they use their valence electrons for bonding is they want to achieve what's called an octet. And maybe this word oct sounds, the prefix oct sounds familiar. Octet means having 8 valence electrons. Everybody on the periodic table wants to have 8 valence electrons. When you have 8 valence electrons, you're considered stable. Stable. So some of these elements are unstable and are a little bit reactive. And so they engage in bonding to help achieve stability. What bonds? Just their valence electrons. Not these inner electrons. These inner electrons are not involved in bonding. They're too close to the nucleus. They're not readily available. All right? So who on the periodic table already has an octet? Well, let's take a look. Column 8. These elements, known as the noble gases, already have 8 valence electrons, so they're stable. They don't like to bond with anybody. I think we've talked about that before. Okay, now that we know about valence electrons, let's quickly write in our notes that the summary statement, which is the column number, is equal to the number of valence electrons. Okay, and let's do one last example here. Okay, let's find sulfur. How many valence electrons does sulfur have in its outermost energy level? You find sulfur. You notice that it's in column 6, so therefore it has 6 valence electrons. If you notice, I haven't labeled my transitional metals because they do not form set number of valence electrons. They have a unique situation going on. Remember, these also, just like their ions, have different things happening outside in their valence outermost energy level. Okay? This outermost energy level, also called the shell, can also be called the valence shell because it holds the valence electron. If these are the valence electrons, these are called the inner electrons. Inner. All right, that's it.